All right, semester 1 review for Algebra 2. Let's get started. Number 1, simplify each expression. So we want to look between our parentheses, and that's the operation we're trying to do. So if we're trying to subtract, then that means that each thing in the second parentheses is going to be subtracted instead of whatever sign it is. So what that means is, like the 7m cubed, I'm going to subtract it so I could put it right here underneath my other m cubed, because those are the two I'm going to put together. Then the 6m is also going to be subtracted. I'm going to subtract it from the positive 7m. And then 6m squared also needs to be subtracted. So I'm going to put that where it goes. And then I'm going to just add like terms coming down here. The other thing we can do is we can go ahead and put in standard form as we go. And so, for instance, we would actually want to do the m cubes first. So 3 minus 7 is negative 4 m cubed. And then I would do the m squareds. 2m squared minus 6m squared is also negative 4 m squared. And then 7m minus 6m is 1m, so we just put plus m. Then if we look at the middle here and we have a plus, then what we're doing is we're adding each of these things. And so if I add 6v squared, well, it's already positive, so I would actually go ahead and add. If I add a negative 2v, then I'm going to leave the sign alone. I'm going to add a negative 2v. I'm going to add negative 7. So when we're adding, we don't change any of the signs. When we're subtracting, like on the first one, we change all of the signs. So again, we want to put in standard form. So I would start with the v squareds. 3v squared plus 6v squared is 9v squared. 2v minus 2v, those actually give us 0v, so they cancel out. 4 minus 7 is negative 3. So our answer is 9v squared minus 3. Just realized I don't have a lot of room here. So let me just fix that real quick. Okay, so if I want to solve this equation, I want to start off by getting the exponent by itself. So b to the 5/6, I want to get by itself, so that means I need to add 8 to both sides, which gives negative 64. And then I want to divide by negative 2. So I get positive 32 equals b to the 5/6. And this is where I want to get rid of my exponent, so I raise each side to the reciprocal power. So the reciprocal of 5/6 is 6/5. And so what happens is 5/6 times 6/5 is 1. Those cancel out, so I get b equals whatever 32 to the 6/5 is, and I can actually type that into my calculator just as 32, and then you use the exponent button. And if it doesn't raise it to an actual like noticeably raise it, you want to put it in parentheses, but 32 to the 6/5 will give us 64. And we can go back and plug 64 in to this original equation and actually check and make sure that works out if we want to. So the next one is very similar, except we start off with everything on the right side being to the 3/2. So I want to start off by raising each side to the reciprocal power. Now, the only time we do this reciprocal power thing is if there's an equation. If there's no equal sign, then we're not allowed to just flip our exponent. Like, that's not how it works. So let me get out a calculator. The 512 to the 2/3 is 64. And then on the right side, the 3's and the 2's cancel, so that we just have what's left, or what was in our parentheses. That's all that's left. And then I have a normal equation I can solve by subtracting 30 and then dividing by negative 2. So n equals negative 17. And again, we can take that and plug it back in up here where n is and work it out and see if we really do get the right answer. Now on 5, 6, and 7, the way these are set up, there's actually a lot of different ways that we can solve a system of equations, but they're kind of set up for elimination. You can put them in the calculator into the matrix and solve them that way, and that might be a good way to go. Or if it's multiple choice, remember you can plug your answers in for x and y to see which one works out. But if we're actually wanting to solve this, I look at my x's or my y's and I say I want to get the same thing in front of both. So I look at this and I say, let me multiply the second equation by 2. I don't actually want them both to be 6. I want one of them to be negative 6. So I'm going to multiply by a negative 2. You have to multiply the whole equation by that negative 2. And then once you do, we're going to ignore that equation and we're going to add the first equation with this one that we just got. So 6x minus 6x cancels, which is the whole point of what we were doing. Negative 4y plus 16y is 12y. Negative 24 plus 24 cancels out, but remember that that means I get 0 if I add those together and they go away. And you might look at this and be like, oh, I did something wrong, but you can divide by 12 on both sides and you get y equals 0 because 0 divided by 12 is 0. So that's an okay answer to get. But we're not done yet. We want to go and plug the y equals 0 back into one of our first equations so that we can get x. So I'm going to do it in the very first one. Make sure if this is y equals that you put it where the y is, not where the x is. So negative 4 times 0 actually goes away so that we have 6x equals negative 24. So then we need to divide by 6 and get x equals negative 4. So our answer is negative 4 comma 0. There's, like I tried to say, there are like 4 or 5 different ways that we talked about how to solve these, and you're welcome to use elimination, substitution. You can graph them if you want to solve for y, or if you remember how to set them up in a matrix in your calculator, you can do it that way. It's just totally up to you remembering how to do it. So on 6, I look at the first equation and I say, well, I just need to multiply that by 2 and I'll get 14x in front here. So multiply by 2, but I have to multiply everything by 2. And so what happens is actually everything cancels out and I get 0 equals 0. Well, what that means is that there's not just one answer like there was on 5. There's actually a lot of answers. We call it infinitely many solutions. Okay, and that's different from no solution. If I cancel everything out so that I end up with 0 equals 0, that's infinitely many solutions. This next one actually is going to show us no solution because I multiply the first one by a negative 2 to try to get 2's in front of my x's. So that gives me positive 2x minus 6y equals positive 26. And so that cancels and that cancels, but the number doesn't cancel. And so I get 0 equals negative 4. Well, 0 doesn't equal negative 4. So what happens is there's not any case ever where this works out to be, to have an answer, to be lines that cross. And so our answer on this one is no solution. Finally, on this first page, we have a word problem where we have to set up our own system of equations and then solve. So we're talking about selling tickets to a performance on the first day of ticket sales. The school sold 2 adult tickets and 1 child ticket for a total of $21. So we can name our adult tickets like X and our child tickets Y, and we can say that 2X plus 1Y equals 21. And then in the next sentence, the school took in $96 on the second day by selling 1 adult ticket, so that's 1X, and 10 child tickets, so plus 10y, and that equals 96. So this is a system now that we can solve to figure out the price of each kind of ticket. So again, I think elimination is a good way to go. Substitution wouldn't be bad on this. And so if you want to see what that looks like, I can solve the first equation for y by subtracting 2x from both sides. And I get y equals 21. Wow, my bad. So y equals 21 minus 2x. And then you would plug this in where y is in our second equation. So we'd have 1x, or just x, plus 10 times 21 minus 2x equals 96. Now if you were enjoying the elimination method from before, feel free to do it that way. You don't have to do it this way. I just wanted to show you another way that you can do these, but if you don't want to do it this way, that's fine. So we get negative 19x. I can subtract 210 over, so that's 96 minus 210, which is negative 114. And then I would divide both sides by negative 19. Get like 5 or something maybe? Oh, 6. So x equals 6. So that means an adult ticket is $6. And then I would plug this back in. The easiest place to do it is here where I solved for y. So y equals 21 minus 2 times 6. And you can actually type that into your calculator. 21 minus 12 is 9. So adult tickets are $6 and children's tickets are $9. That would be our answer. Name each polynomial by degree and number of terms. So the degree, we look at the biggest exponent, which is 5. So that's quintic. And then by terms, there's 2 terms, which makes it a binomial. On number 10, our degree is 2, so that's a quadratic. Think of like a parabola with all those x squareds. Then there's only 1 term, which is called a monomial. On number 11, we want to focus on this point at the end, because what's happening is we have an x value here of 4, and then our graph keeps going to the right, and we have a y value of 1, and our graph goes up. So we want x to be greater than or equal to 4, and y to be greater than or equal to 1, okay? Because we're starting at an x value of 4 and going right, we're starting at a y value of 1 and going up, which means our answer would be B. Number 12, we're trying to match the picture with the correct set of equations. And so what's important is that we remember that x lines are the ones going up and down. So x has something to do with 4, okay, because 4 is where we're crossing on the x-axis. It's equal to, so we'll have a line underneath, and then since it's shaded to the right, those are the numbers that are bigger than 4, so we put a greater than symbol. Then for our y, which is our horizontal line, well, it has something to do with 2, because that's where it goes through the y-axis. We don't put an equal sign because it's dashed instead of solid. And then we've shaded down, so that's less than 2. So that's the answer choice we're looking for, which is C. Now, 13, I would look for, like, on one of these lines, maybe try to write that equation. So on this line, I'm going through -1. That's my y-intercept. I have a slope of up 1 and right 1, so that's a slope of 1, so that's 1x, or just x. And then it's a solid line, and we've shaded this direction, which is less than. So y is less than or equal to x minus 1. And then I would look at the other line, which has a y-intercept of -5, has a slope of up 1, left 1, which is negative x, and then they've shaded this direction on that line, which is a greater than, and it's got a dashed line, so it's not equal to. The other way of doing this would be to graph each answer choice in our calculator and see which lines match up, like which is the best situation for what's going on. And 14, that's probably one of the, I guess, better situations is to try to do that, because these don't really solve particularly well as far as like, we actually can use solving by intercepts like if we wanted to, but I know in my class we haven't really talked about that. So like for A, and all of these are really similar equations, so you might not need to do a ton of work, but for part A, to solve for y, I need to subtract 2x over to the right side, and then I need to divide by -1. Everything gets divided by -1, and it changes this and makes that go the other way. So y is less than or equal to positive 2x minus 3. So we can actually look and see right now, 1, 2, 3, -3 is down here, and a slope of 2 is up 2 and over 1, so that doesn't look like that's happening. But I do have a positive 3 and a down 2 over 1, so it can't be A, because that doesn't match any of our lines, but I guess we don't really know enough information to know which one of these to pick, because those are all a little bit different. So now I can do B. So I can solve for y here, and by subtracting 2x over, so y is greater than or equal to -2x plus 3. And again, if I want to, I can plug this into the calculator. So I go up to 3, and then I'm going down to right 1. That's right, and greater than or equal to would be this side of the line. So that part's good. And so actually that's enough for us to know it has to be this, because these don't quite match up. This has a less than sign instead of a greater than sign, so it's got to be B. All right, we've got a lot of factoring here, and the tricky thing with factoring is you do different things for different scenarios, and that can be really tough to remember. But overall, the concept is that we want to break things up into 2 or more things that multiply to get what we're starting with. So when I have 2 terms, and I see that I have squareds in one or both of them, what I want to try to do is split up the first term into the front of the parentheses, where I have the same thing in both. So 9x squared would split up into 3x and 3x. And then I want to split the second term up to be the second thing in each parentheses. So -y squared splits up into y and y, but one would have to be negative. So I get 3x minus y and 3x plus y. That one can be tough to remember what to do on that one. If there's 3 terms, then and there's a number in front of our squared, we want to do slide and divide. So I'm going to slide the 9 over, which gives me k squared minus 30k. I do 9 times 25, which is 225. Now I'm going to look for 2 things that multiply to get 225, that add to get my middle number, which is -30. That one's kind of a tough one, but it's -15 and -15. So I take the number I slid and I divide by it. I slide and I divide. So slid, divide, because it rhymes. Alright, so I simplify this if I can, which they both divide by 3. So I get 5 over 3. But it doesn't simplify completely, like I still have a fraction. So I end up writing this as the bottom number in front of k, so 3k minus 5. This is the exact same thing as the first parentheses was, so I have 3k minus 5 again. And since the 2 parentheses are the same, I can actually write this as 3k minus 5 squared. That's probably my best answer. Now I want to look at all 3 of these terms on 17. and I want to say, well, I could try to slide and divide, but they've all got an n, and so I might as well take the n out, and while I'm at it, they all have a number you can divide into each, and we want to pick the biggest number possible, so we're going to actually take out a 4n, which means we're dividing each of these terms by 4n to see what's left over. So this is 4n squared. No, just kidding. That was a joke. Haha. If I divide by 4n, I just get n squared. The 4 goes away. And then I take a 4n out of 4n squared and get n. And then 4n out of negative 288n. So negative 288 divided by 4 is negative 72. I had an n, but I took it out, so I don't have an n. Now I would factor this parentheses saying what multiplies to get negative 72, that adds to get a 1. So the 4n stays outside, hanging out. Inside of my parentheses, I've got n and n because of n squared. To multiply to get 72, where I'm 1 apart from each other on my numbers, I would use 8 and 9. And since I want a plus 1, I'd use plus 9 and minus 8. We didn't slide anything, so we don't have to divide. This would be our answer. And you might be thinking, how come we're not setting equal to 0 and solve? Because they just said factor. They didn't ask us to solve. Factoring means you stop once you're in your parentheses. 18 is actually easier than these last couple have been. We're going to split the m squared up into m and m, and multiply. See what multiplies to get negative 21, that adds to get negative 4. And so when I do this, if I get stuck on something, I actually go through and say, well, I know 1 times, well, I messed those up again. 1 times 21 I know goes. 2 doesn't divide, but 3 does. And I personally do a very strategic thing if I can't figure out what it is just off the top of my head. And now I can practice subtracting those and say, well, which of those will give me a negative 4? So I pick 3 and 7. So I should have minus 7 and plus 3. And that's my answer. On 19, we're back to sliding and dividing. Slide the 5 and get x squared minus 17x minus 60. So what multiplies to get negative 60? That adds to get negative 17. You might think, well, 5 and 12 would work if we had different signs here, if this was a positive, okay, but you can't subtract 5 or subtract 15 and 5 and 12 don't subtract to get negative 17. So instead we want to think about some other numbers. So we have 1 and 60, 2 and 30, 3 and 20. Hey, those subtract to get 17. So I have x minus 20, x plus 3. Because when I add these together, I want to get a negative, so the bigger number is negative. Doing slide and divide, so I have to divide. This actually divides, so that's x minus 4. This doesn't divide, so I move, and it doesn't simplify either, so I move the 5 in front. And I get x minus 4 times 5x plus 3. Anytime you have 4 terms and you're asked to factor, the only way to factor is to factor by grouping. So we want to look at the first 2 and we want to say, is there any number I can divide by? Yes, a 3. Are there a's that I can take out? Which there are. I can take out a squared. And then see what it is once you've taken it out. So 3a squared out of 15a cubed is 5a. 3a squared out of 18a squared is 6. Okay, and then 3a squared, oh, no, I don't look at that. Now I'm looking at this problem separately. What do they have in common that I can divide by? Which they have 5 in common. If I divide both those numbers by 5, I get 5a plus 6. So what you want to have happen is that we have these parentheses that are the same. So I can write down that parentheses, 5a plus 6, and then write down what's left over on the outside, which is 3a squared plus 5. That's my answer. And now, the only difference on 21 is when we split up u to the fourth, that means we'll have u squared in each of our parentheses. But we do need to slide and divide, which I'm going to not move over that answer up there. Okay, slide and divide, so u to the fourth plus 19u squared plus 70. So I'm looking for what multiplies to get 70, that adds to get 19, which we have 1 times 70, 2 times 35, 3 and 4 don't go in, 5 goes into 70 14 times, so 5 plus 14 is 19. So plus 5 plus 14, divide by the 2, and on the first one it doesn't divide, so that's 2u squared plus 5. The second one does divide, so it's u squared plus 7. 22. There is a formula for this, and I'm going to go and write both formulas up here. If I have something cubed plus something else cubed, then I can split that up into the somethings added together times a squared minus ab plus b squared. Or if they're subtracted, then I just change a couple of the signs, like so. So what happens is I have something cubed plus something else cubed, and you may not realize that this is something cubed, but you can get on your calculator and do math number 4, I think it is, and do the cube root of 216 and get 6. So what happens is that a in our formula is u, because u is the something that's cubed, and then b in our formula is 6, because 6 cubed is 216. And now what I started with was this side of my formula, so my answer will be this side of my formula. So I do a plus b, so u plus 6, times u squared, minus u times 6, which is 6u, plus b squared, so 6 squared, which is 36. So this is my answer. Number 23 is really easy. So using the graph to find the roots. Roots are another word for solutions or zeros or answers. I just need to figure out where those two places are where we're crossing the x-axis, which is at -3 and 0. So those are our answers. 24, solve the equation by factoring. So I'm going to slide and divide. Now it says to use factoring, but technically you could do this other ways, like the quadratic formula. You could graph it and find the zeros. Lots of ways. So I want to look at what multiplies to get -150 that adds to get -19. So it's not 15 and 10, and it's not 5 and 30. So not 3 and 50, 6 and 25. So -25, v plus 6, and then I'm going to divide by what I slid by, which is the 5s. So what I get is v minus 5 times 5v plus 6. Because I'm trying to solve now, I actually want the answers. I said each part equal to 0. And so v minus 5 equals 0 means v equals 5. It's one of my answers. Then when I subtract 6 from both sides, I get 5v equals -6. I divide by 5 and get -6/5. Okay, so if it says solve and I have a squared, but I don't have just a normal x term, then I can actually do this pretty simply. If you don't realize you can do it the way I'm about to do it, you would want to get everything on the same side and quadratic formula probably. But what I can do is I can actually solve for the x squared by subtracting 8 on both sides, which gives me 5x squared equals negative 103. Then I divide by 5 on both sides, and I get x squared equals negative 103 over 5. Then I square root, and I get x equals plus or minus. Well, the only thing I can really do to simplify this is put an I on the outside. I can rationalize this by multiplying by square root of 5 on the top and the bottom. But I don't know that I really think that's necessary. I feel like this is an ugly looking square root anyway. So you end up with an I and then square root of like 515 over 5, which, I mean, I feel like this answer looks about as pretty as the second one personally, but just letting you know that you can keep going and rationalize it and get this. So then on 26, this actually works out to be a much nicer answer. I add 5 on both sides and get 9v squared equals 25. Divide both sides by 9, and I get v squared equals 25 over 9. Square root both sides, and I get v equals plus or minus. Remember, the plus or minus happens anytime we square root, because if we start with the squared, we want 2 answers. The square root of 25 over 9 simplifies because you can take the square root of 25 and get 5. You can take the square root of 9 and get 3. So our answer is positive and negative 5/3. 27, I want to divide by negative 5. So that I have m squared equals, that goes in 24 times. So that's m squared equals negative 24. Square root on both sides, m equals plus and minus because it's a square root, and then we want to simplify this, so that means making a factor tree, or the cake method is something your teacher might use instead of a factor tree. We want to look for pairs of numbers, so there's a pair of 2's. Need an I on the outside because it's a square root of a negative number. Then on the inside I put my numbers that are left over, which is 2 times 3, which gives me 6 underneath. So this is my answer. Now, 28 says solve with the quadratic formula. So here's the quadratic formula. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Okay, so I have a, b, and c if it's in standard form, which it is. So x, or in this case I guess it would be a, equals negative b. So a negative 5 plus or minus square root of negative 5 squared minus 4 times a times c all over 2 times a. So 2 times 11. What you want to do is not try to stick this whole thing in the calculator. You just want to put what's underneath the square root without the square root symbol. If you put in the square root symbol, it's likely to give you an error. Okay, so I can do negative 5 is a positive 5. Then if I plug this in, what's underneath my square root, I get negative 195, I think. Let me make sure. Yes, negative 195. I didn't put the square root in my calculator, so I need to put it underneath a square root since I haven't taken the square root yet. 2 times 11 is 22. And then we want to look at that square root and see if there's anything we can simplify. Well, if I make a factor tree, I know I can divide it by 5 because it has a 5 on the end. So I can make a factor tree with 5 and 39. 39 goes to 3 and 13. And then that's it. There's no pairs of numbers, so all I can do is write this as 5 plus or minus I, square roots of 195, over 22. All right, so now we're going to simplify using imaginary numbers. So the important thing to remember is that I squared equals -1. So anytime we end up with an I squared, we want to change it to -1. So if I'm subtracting, it's like what we did earlier. I'm subtracting a -1, which means I'm really going to add 1. Okay, and then I'm subtracting a positive 6i, so I want to subtract 6i. So I add like terms. 7 plus 1 is 8. 2i minus 6i is -4i. So my answer is 8 minus 4i. This next one, I'm multiplying, so I need to FOIL. -4 times -1 is +4. -4 times I is -4i. -8 times -8i times -1 is +8i. 8i times I, -8i times I, -8i squared. So we want to add our like terms in the middle. That's 4i. This I squared changes to -1, so this is really a +8i, not I anymore actually, +8 plus 4, which is 12, so our answer should be 12 plus 4i. Now on 31, all we have to do is multiply by I on the top and the bottom, but you actually might think about multiplying by a -I, and it actually might help to do that. You don't have to multiply by the 10, but if you do multiply by the 10 also, it should work out. So on top we're going to distribute, so 5 times -I is -5i. I times -I is -I squared. And then on bottom, 10i times -I is -10i squared. Our I squareds we're going to change to -1s. So on top that gives us -5i plus 1. And on bottom it gives us +10. Now the reason to multiply by a -I instead of a regular I is just to get the negative that would have been on the bottom off of it. If you had just done a positive I on top and bottom, you'd get 5i minus 1 over -10, which these are the same thing, just they have different signs. And so the one that's more likely to be an answer choice is this one right here. So just keep that in mind. So on 32, we want to multiply the top and bottom by the conjugate of the bottom. So that means change the middle sign. And we're going to FOIL on top and bottom. So here we go. On top, that gives us -32 plus 32i minus 8i plus 8i squared over -8 times -8 is 64. -8 times 8i is -64i. -8i times -8 is +64i. -8i times +8i is -64i squared. Now, every single time we do a problem like this where we're trying to get the i's off the bottom, these i's in the middle here that when we FOILed should cancel. Okay, and then what I want to do is add like terms and change my I squareds to -1s. So on top I have -32 minus 8, which is -40. Then I have 32i minus 8i, which is 24i. On bottom I have 64 plus 64, which is 128. And then to finish off, I just want to divide by the biggest number I can with all 3 of these numbers. Okay, you can't just do 2 of them, you have to do all 3 of them. So I know I can divide them all by 4, but I think there might be a bigger number. Divide -40 by 4, divide 24 by 4, and you get 6i 128 divided by 4 is 32. And so, yeah, I was right. We can actually divide them all again by 2. But if one of them was not divisible by something, we would just leave it. Okay, they all have to divide by the same number. 33 and 34 are going to involve factor trees and simplifying, like 256. I actually think we might be able to take the square root of 256. I think is it 16 times 16? Yes. And so if you realize that, that will save you some time, because if it's 16 and 16, I have a pair of 16s. There's a negative underneath, which means my answer would be 16i. But if we didn't know that, if we didn't try the square root of 256 just to see, then we'd make a full-blown factor tree and look for pairs of numbers. 34, 392, I'm pretty sure doesn't go straight to a nice number. I'm actually going to put my factor tree up here because I feel like it's going to go on for a while. I can divide by 2, get 196. And 196, actually, that's 13 times 13. That's kind of a tough one. No, that's 169. So forget I said that. Duh. 196 divided by 2 is 98. 98 divided by 2 is 49. 49 is 7 and 7. Okay, so our pairs of numbers, we've got a pair of 2s and a pair of 7s. So that's a 7 and a 2 on the outside, which gives us 14. Then we have a 2 left over for the inside. But I'm leaving a space because I have to deal with my x's and my y's. That's x cubed, so you can think of it like x written out 3 times. I've got a pair of x's, which puts an x on the outside, but I have an x left over without a pair, which goes on the inside. My y's, I have 4 of, so I have 2 pairs. So I put y on the outside twice, which would be y squared. So my answer is 14xy squared, square root 2x. All right, with cubed roots, the important thing to remember is we're looking for trios instead of pairs. So I make a factor tree for 192 and get 2 and 96, and then I can do 2 and 48, then 6 and 8, 2 and 3, 2 and 4, 2 and 2. My factor tree got a little away from me. So I have, here's 3 2s, and then here's 3 2s, and all that's left for the inside is a 3. So on the outside, I've got the negative 5 I started with, and then I've got 2 2s. And then on the inside, I'll have a 3, but I also need to deal with the A's, the B's, and the C's. So if I have 5 A's, and I'm looking for a set of 3, I have a set of 3, which puts an A on the outside, and I have 2 A's that'll go back on the inside. With B's, there's 4 of them, so I take these and put 1 on the outside, and then I'll have a B left for the inside. C's, there's not enough of them to drag any outside, so underneath my cubed root will be 3 from my numbers, A squared, B, C squared. And then I would finish off by multiplying these numbers on the outside. Negative 5 times 2 times 2 is negative 20, AB cubed root 3A squared B C squared. Wait, that's quite an answer. 36, I'm looking for sets of 4. I know that 4 of 5 is divisible by 5. Hey, that's our, never mind. And I get 81, and then I can do 9 and 9. 9 and 9 go to 3, and 3 and 3 and 3. So I have a set of 4 3s. So I'll have a 3 on the outside and a 5 left over. There's already a 3 on the outside though, so that's 3 times 3. We can try to do this without writing it out, but if writing it out helps, that's fine. How many sets of 4 are there in A to the 5th? there's 1 with 1 left over. So the 5 is on the inside and then a is on the inside. B squared doesn't have enough b's to drag any out. C to the 4th has exactly a set of 4, so we put a c on the outside and nothing on the inside. So now I just need to rewrite this. 3 times 3 is 9ac on the 4th root of 5ab squared. On 37, we can't add them together right now because they don't have like square roots, but we can simplify our square roots and then see what happens. Like, this is a pair of 2's. So I have 2 square roots of 3, which doesn't change, plus I've got 2 times 2, which is 4 square roots of 3, and then a pair of 2's and a 6 on the inside. So the pair of 2's multiply with the 3 gives us 6 square roots of 6. So these two are like terms, so I get 6 square roots of 3 plus 6 square roots of 6. I'm going to distribute here. Negative 3 square roots of 3 times the square root of 2. The insides multiply together or the outsides multiply together, but I don't multiply something outside a square root with something inside. So this will be negative 3 square roots of 6 and then negative 3 square roots of 18. Simplify if possible. This simplifies to be 3 gets moved to the outside and a 2 is on the inside, so it's negative 3 square roots of 6 minus 9 square roots of 2. Those aren't like square roots, so we have to leave it like that. Now, there's a couple different ways to approach 39. The easiest thing to do is to see if the fraction simplifies. 10 over 8 simplifies to be 5 over 4 by dividing the top and the bottom by 2. And if we do that, then I say, well, I can't do anything with square root of 5. Square root of 4 is 2. Got my square root off the bottom, so there's my answer. If that doesn't happen, where we can get rid of the square root on bottom like that, remember, like at the beginning here, the other way of doing this would be to multiply the top and the bottom by square root of 8. And you get square root of 80 over square root of 64, which is 8. You simplify the top, which gives you 4 square roots of 5. Then you simplify the outside, which gives you square root of 5 over 2. So see, we get the same answer either way. The first one is a little bit quicker, but if you don't remember it, then it's kind of hard to do. Okay, cubed roots, we're looking for trios. So 2 and 10, 2 and 5, there's not a trio, so the top is going to stay the cube root of 20. 27 is 3 and 9, 9 is 3 and 3. So we have a set of 3, and the thing to remember is I can take the cube root of a negative number and I get a negative answer. So this is a negative 3 on bottom, or we can just rewrite it with the negative in front of the whole fraction. Because the top was positive, the bottom was negative, it makes the whole fraction negative. So this would be our answer. On 41, since we have 2 terms on bottom, we want to multiply by the conjugate. Negative 4 minus 5 square roots of 2 on top and bottom. So distribute on top. Foil on bottom. But again, our outer and inner terms should cancel out. So first is 16. Last is negative 25 square roots of 4. Outer and inner terms cancel. The top I can't do anything with at the moment. The bottom, the square root of 4 is 2, so this is negative 50. 16 minus 50 is negative 34 on bottom. Then all I can do here is they're all negative, so I can change them to all be positive, but they don't divide by the same number all the way through. So this is my best answer right here. Now, 42, I'm going to do 125 to the 5/3 and r to the third to the 5/3. So 125 to the 5/3 I can put in my calculator. And get 3,125. And then 3 times 5/3, I can put that into the calculator and get 5, so this is r to the 5th. The other way of doing it is to remember that this is power over root. So I would do the cubed root of, and I'm going to put this in parentheses, to the 5th power. Do the cubed root of 125r cubed, which is 5r, and then raise it to the 5th power. So 5 to the 5th, r to the 5th, which is 3125 r to the 5th. Speaking of power over root, if we're given something that's a radical and we're asked to write it in exponential form, that's what they're talking about. So the root, if it doesn't have a number, is a square root, so that's a 2 on bottom. Power is 5, so this is 6x in parentheses to the 5/2. You might ask, how do I know to put it in parentheses? If this is in parentheses, this better be in parentheses, like for sure. And just in general, like, parentheses are good. Number 44, find each product. So we want to FOIL this out. So 4n times 5n is 20n squared. 4n times -4 is -16n. 6 times 5n is 30n. 6 times -4 is -24. In general, you want to check the middle terms to see if you have like terms, which we do. So this will be 20n squared plus 14n minus 24. That's our answer. Here we can't FOIL exactly because we have too many terms in the second parentheses, so we're going to distribute the 2x through and then distribute the -1. So 2x times 8x squared is 16x cubed. (2x times -x is -2x squared). 2x times -8 is -16x. When we distribute the -1, a trick that we can do is write it underneath what we've already got. -1 times 8x squared is -8x squared. -1 times -x is plus 1x. -1 times -8 is positive 8. Writing it like that helps us see where our like terms are so that we can just add coming down. 16x cubed minus 10x squared minus 15x plus 8. When we divide, if we're only dividing by one term, what we want to do is write that underneath each thing we've got at the beginning. So 2x cubed over 10x cubed plus x squared over 10x cubed plus 2x over 10x cubed. And we're just going to simplify each of these. Like 2 over 10, we can divide each by 2. That gives us 1/5. The x's cancel, so we get 1/5. X squared over x cubed. The top x squared cancels, and it leaves us with just x to the first on the bottom. There's not a number on top, so we're going to do 1 over 10. And there's an x on the bottom, so 1 over 10x. And then the 2 and the 10 cancel like before. That x cancels and makes this a squared because it's 3 minus 1, so it gives us 2 on bottom. So 1 over 5x squared. When we've got more than one term, like on 47, the easiest thing to do is to use synthetic division. So you set what you're dividing by equal to 0 to figure out what to do the synthetic division with. We get positive 5. That's what goes in our box. And then we use the coefficients. We drop the first number, then we multiply. 5 times 1 is 5. Negative 4 plus 5 is 1. 5 times 1 is 5. Negative 8 plus 5 is negative 3. 5 times negative 3 is negative 15. 11 minus 15 is negative 4. We start with 1 degree less than we had originally, because m cubed divided by m means we'll start with 1m squared plus 1m minus 3 minus our remainder of 4, which we write over what we were dividing by, which was m minus 5. So this would be our answer. Now this one is very similar because we're going to set equal to 0, subtract 4 to figure out what to do our synthetic division with. But the trick is that this is 1x cubed, 4x squared, but they don't have an x term, so we need a placeholder for that x, where that x term should be, and then we put the negative 1. So we drop the 1, multiply, add, multiply, add, multiply, add. So we started with x squared, so this will be, we started with x cubed, so this will be 1x squared plus 0x plus 0 minus our remainder. And so we don't actually need the plus 0x and the plus 0, it's just x squared minus 1 over x to the 1 over x plus 4. 49 through 52 say find all the zeros, so what it wants is for us to solve for x, and there's a couple different ways that we can do this. Like you technically can plug these into the calculator and try to find the zeros that way. The problem with that is if you have any imaginary zeros, your graph doesn't have a way of telling you what those are. So your best bet is to factor if you can remember how to do it. So on 49, they all have an x in common, so we'd start off by taking out an x. And then we would slide and divide. And we'd say, what do I multiply together to get negative 50? That adds to get negative 23. Whoops. So that will be negative 25 and positive 2. And then we divide by what we slid earlier, which was 5. So we have x times x minus 5. This doesn't simplify, so that'd be 5x plus 2. And now we set each part equal to 0 to figure out what our x's should be. So x equals 0, which we don't have to do anything to solve. X minus 5 equals 0, which we'd add 5. So x equals 5 is an answer, and then 5x plus 2 equals 0. We need to subtract 2. And then divide by 5. On 50, since we have 4 terms, we have to factor by grouping. So they have an x squared in common, which leaves us with 3x minus 1. These two have a 3 in common. JK, they have a 2 in common. I can totally divide. Okay, they have a 2 in common, and then you get 3x minus 1. And then we put the 3x minus 1 that they have in common, and the x squared plus 2 goes in the other parentheses. And then we set equal to 0, and we work on solving now. 3x minus 1 equals 0, x squared plus 2 equals 0. So the 3x minus 1, you add 1 over and divide by 3, so we get x equals 1/3. X squared plus 2, you want to be careful, we subtract 2, get x squared equals negative 2, square root. remember if we square root in an equation, that gives us a plus or minus. It's a -2, so that'll be an I on the outside, and I can't actually take the square root of 2, so it's plus and minus I squared to 2. Remember that we're supposed to get however many answers that our degree is. So this is a third degree, so we got 3 different answers, which is why, like, the calculator definitely wouldn't have told us the plus and minus I squared to 2 on that one. It just would have given us the 1/3. So factoring by grouping again on 51. Take out an x squared. Here we only have a negative in common, and we have to think about, should I take the negative out? I should, because I want the inside of my parentheses to be positive 5x plus 1. So I have 5x plus 1 in one parentheses and x squared minus 1 in the other. So I set each part equal to 0. So I subtract 1 and divide by 5. That gives me x equals -1/5. I add 1, get x squared equals positive 1, square root, and I get x equals plus or minus the square root of 1 is 1. So positive and -1, -1/5. So that's one where the calculator would give us the right answer. 52. There's only 2 terms, and so for whatever reason, I know that my students miss this a lot because I guess they forget how to factor it. They have an x in common, and they can be divided by 7. So we take a 7x out, and that leaves us with 7x plus 4. We set each part equal to 0, so 7x equals 0, and then 7x plus 4 equals 0. So I divide this by 7 on both sides to solve for x and get just 0 for one answer. Here I subtract 4 and get 7x equals -4, divide by 7, and get x equals -4/7. Also on this one you could do the quadratic formula. Also on 49 you could use the quadratic formula to solve the part inside the parentheses here. And you can also use the calculator on this one, which -4/7 it would give you as a decimal, and you'd have to be able to figure out which one's the right answer. X squared minus 9, we can go one of 2 ways. We can factor into x plus 3, x minus 3, then set each part equal to 0 and solve. Or if you remember, you can add 9 to both sides and get x squared equals 9, square root both sides, you get x equals positive and -3, which is the same thing we get from setting each part of this equal to 0. So either way, whichever one you can think of first. We want to approximate the relative minima and relative maxima of each function to the nearest tenth. So you get on your calculator and you go to y equals and you type in x to the 4th minus x cubed minus 3x squared plus 3. You press graph, and it actually on this one gives you kind of a interesting looking graph. I'll show you just so that you know if you have it graphed right. Something like this-ish. And so we actually, every place that we have like a valley is a minimum, and every place we have like the top of a hill is a maximum. So we actually have to find 3 things. So you do a second trace, and for instance I can go to minimum and find the minimum on the left side by doing left bound, right bound, and guessing. Remember, the left bound and the right bound, you want to surround your minimum. Okay, so that farthest left point is -0.9. It says round to the nearest tenth, and then the y value is 2.0, so that's a minimum. And then I'm going to find the maximum next. That's in the middle. I think in general it works best if you go from left to right like that, because of where your cursor ends up. The max is at 0.3, which we probably could have guessed that. And then our other minimum, second calculate minimum, left bound, right bound, yes, 1.7 and negative 2.2. Alright, so these next few problems all have us using our calculator to find things. So this one, 55, is relative minimums and maximums again. So you would go to y equals, clear out what you've got, type in x cubed minus 3x squared plus 1, graph, get like a normal-ish looking cubic function. So there's a maximum at, if I go second trace and pick maximum, it looks like 0, 1. And then minimum is over to the right of that. And I get 2, negative 3. (56) approximate the real zeros, and so zeros have their own separate thing. Like maximums and minimums, you look for the word maximum and minimum. Zeros, you're looking for the word 0. So we go to y equals and type this in. It goes through 2 times. And so you do second calculate, and it's the second option. When you do left bound, if I'm finding the left 0, I want to be below it, then I want to be above it, and then I want to go back to the middle, and I get x equals negative 1.3, and then I do second calculate 0, and then our left bound should be above, our right bound should be below, so that's 1.9. Again, zeros, so type in this new function. This only has 1 0. So second trace 0. Probably don't have to be super careful on where you put your left and right bound on this one, since there's only one of them. I get x equals 1.7. 58, evaluate the function to find f of 5. We put a 5 in for all of the x's. So 4 times 5 plus 4, which is 24. Find the vertex. You can do this by hand by looking at these two numbers. You change what's inside the parentheses and you leave alone what's outside. Since it's a positive and a positive 5, it's a minimum because it's a parabola that's opening up. But you also can just type this into y equals on your calculator and find, like, it'll show you that it's a minimum, and then find the point using the same methods we did earlier to find the minimum. And I would recommend that on 60, and you can actually tell really easily without even finding it that it's at 0.3 and it's a minimum. And back in the day we did this formula, negative b over 2a, and so there's not actually a b, so we get negative 0 over 2 times 1/3, which is 0. You plug it in and you get 3, but it's really easy to just look at that one or calculate it, whichever way you want to go there. Number 61, we want to do x plus 3. We're changing all the signs, and then we're going to multiply this out. So I'm going to pick 2 of them to multiply together, foiling fashion. X squared minus 4x plus 3x minus 12. Add my middle terms. And then multiply by the one I haven't multiplied by yet. So distribute the x. distribute the -5. And I get x cubed minus 6x squared minus 7x plus 60. And I guess technically we should put like y equals or f of x equals or whatever. Alright, perform the given or indicated operation. This means to add our functions together. T plus 2 plus t squared plus 1 would be t squared plus t plus 3, because we just add our like terms. This is saying f plus g of t, which just means that t is in our answer instead of us having to plug in a number. Like if they give us a number here, we have to plug it in at some point. G of x minus f of x, well, g of x is 2x minus 2. F of x is x plus 2. So if we subtract those, we need to distribute the negative, drop our parentheses, and get 1x minus 4. Multiply. So that's a foiling situation. You know it's multiplication because it's a little dot, closed dot, whatever you want to call it. 66 is what you don't want to confuse it with when it's an open dot. This is negative 2x cubed plus 8x squared minus 3x squared minus 12x. Add the like terms in the middle. We're dividing and plugging in a -5, so we can actually do this a couple different ways, but might as well just do it this way. Plug in the -5 to G, plug in the -5 to F, and then we'll divide them. So we want to do the top, which is 17, the bottom, which is -16. So the only thing you could do is put the negative in front, because that negative on bottom makes the whole thing negative. That's our answer. Okay, this is F composed with G, which means you're going to take G and plug it into F. So I'm going to take 4x plus 1, and I'm going to put it right here where this x is. It means the same thing as f of g of x. So if it helps you to think of it that way, then think of it that way. Okay, but I'm taking 4x plus 1 and putting it here where this x is, so I need to distribute and add like terms so that I get 16x plus 9. This one we can treat a little differently. You always want to go backwards. 6 is going to go into f, and then our answer is going to go into g. So f of 6 equals 2 times 6 minus 5, which is 12 minus 5, which is 7. Now we're going to take that and put it into g. So we're doing g of 7, which is 3 times 7 plus 1, which is 22. So that's our answer. To find the inverse of a function, you want to think of the f of x like it's y, and this over here is x. Switch the x and the y around, and then solve for y. So subtract 12, and I get 5y equals x minus 12, and then divide by 5, and leave it y equals x minus 12 over 5. Alright, to determine if they're inverses of each other, you can graph them, one in y1 and one in y2, and see if they're symmetric across this diagonal line here. That can be a little tricky though to tell, so I would recommend that you pick one of them. To think of these like y's and x's. Pick one of them to solve for the inverse and see if you get the other one. So in this one I would switch the x and the y, add the 5 over, and then divide by 9, and then I check and see x plus 5 over 9, that's what that is. So yes, those are inverses of each other. So let's do the same thing here. This would be y and x. y, and x. Now, I can almost guarantee you that if you have two roots that are different, that this will be a no. But let's just humor them real quick. By them, I mean, I don't know who I mean. To get the fifth root away, we'd have to do the fifth power on each side. So x to the fifth equals negative y plus 2, and then I'd subtract 2, and then I would change the signs, and that in no way looks like what we've got, so that's a big fat no. Like I said, you might be able to tell just from looking at them whenever they're totally off, but if not, once you start solving, you might be able to tell. Find the zeros by factoring. What multiplies to get negative 8 that adds to get negative 2? How about negative 4 and positive 2? So we set each part equal to 0. So x equals 4 and negative 2. So here I want to get my square root by itself. So I'm going to subtract 8 from both sides and get square root of 3x plus 12 equals 6. Now I want to square both sides. So I get 3x plus 12 equals 36. Subtract 12. Divide by 3. Go back in and check. And it does work, so x equals 8 is an answer. Here we are already solved for our square root, so square both sides. We get 110 minus x equals x squared. Get everything on one side because we've got a pesky x squared. That means we'll have to factor or quadratic formula. But what multiplies to get negative 110 that adds to get 1 is actually not too bad. 11 and 10. Set each part equal to 0, so we get negative 11, positive 10. Check and see. So this one isn't going to work because I'll get square root of 121, which is positive 11. But that doesn't work because I can't get a negative 11. So negative 11 doesn't work if I plug in. Sorry, I spaced because I was trying to figure out how 10 was going to work, but don't worry. 110 minus 10 is 100. Square root of 100 is 10, so 10 really is an answer. All right, we want to figure out the equation that's going on 74 and 75. If you can think about the absolute value normally has a v right here at 0, 0. Then we've moved left 3 and up 2, which the left and right, that's the negative direction, but it's always the opposite, so it would be a plus 3 on the inside. Up 2, though, will be a plus 2 on the outside, so our answer is D. So our answer is D, but if you didn't know that, you can put it into y, each of these into y equals to get the absolute value. You do math, go to the right, and then you pick ABS, and you type in, and you either close the parentheses around the x minus 3 or x plus 3, or get out of the absolute value bars after that, and you should get x plus 3 in absolute values plus 2. Okay, 75. Again, we can plug these into our calculator and see which one looks closest. Since we're opening down, we're looking for a negative, so it can't be B or D. And then we can think about where our vertex is. It's right 1 and up 2. Right 1, up 2 would be C. But again, we can plug each of these into the calculator and figure out. 76, the way that it wants you to do it is synthetic division, where the answer is your remainder. And since this is n equals negative 4, we don't change the sign. so our answer is -9. You actually can just do f of -4 and you'll get -9. And since it's going to be multiple choice, you can do whatever you want technically, and I personally won't pay attention. Give the name and degree of the polynomial function. I like to count the terms. 3 terms means it's 4th degree because it's always one higher, and that means it's a quartic polynomial.